In the world of biotechnology, there's this incredible invisible arms race happening right now. On one side, you've got artificial intelligence designing amazing new proteins that could, cure diseases. And on the other side, our digital defenses are literally racing to keep up, making sure that same tech can't be used to cause harm. So let's get into it. This really is the central question, isn't it? Can AI be used to cook up a dangerous biological sequence that looks so harmless that it just slips right past the digital guards we have in place? That's the exact question a team of researchers set out to answer. To really get a handle on the problem, you first have to appreciate that AI in this field is a classic double-edged sword. I mean, it's a tool, right? And its impact depends completely on who's using it and why. On the good side, it's incredible. AI can design brand new proteins to create revolutionary medicines, accelerating breakthroughs at a speed we've just never seen. But on the flip side, the exact same AI tools could be used to create novel toxins or scary viral proteins, what researchers call proteins of concern. So here's the really tricky part. AI can take a known dangerous protein and just rework it, creating what's called a synthetic homolog. Now, this new version might fold into the exact same dangerous shape and do the exact same bad thing, but its underlying DNA sequence can be so different from the original that our security software, which is basically just looking for known bad guys, doesn't even recognize it. It's like a threat in disguise. But a bad actor could take it even one step further to slip past our defenses using a really clever strategy that has researchers worried. It's called the fragmentation attack. Let's take a look at how this works. Okay, so here's the playbook. First, they design their dangerous protein using AI, making sure its sequence looks nothing like any known threat. Step 2, they chop up the DNA sequence for that protein into lots of small, random-looking pieces. Third, and this is the clever part, they could order these harmless little fragments from a bunch of different DNA synthesis companies. And finally, once all the packages arrive, they just assemble the pieces of the puzzle into the full-length threat. And this is where the experiment comes in. Researchers basically mimicked this exact attack. They took AI-designed proteins of concern, translated them to DNA, chopped them up into different lengths, and then they fed those fragments into our digital screening systems to see could they be detected. They really put our defenses under a tough, realistic stress test. So let's talk about these digital guards for a second. What are they exactly, and how are they supposed to work? They're called Biosecurity Screening Software, or BSS. And honestly, the best way to think about them is as a spell checker, but for DNA. So when a company that makes DNA gets an order from a customer, this software automatically scans the requested sequences to see if they match any known dangerous sequences, flagging potential hazards before they're ever even synthesized. For this study, the researchers tested 4 different BSS tools. And these weren't just any old tools. They had all been recently patched, specifically to try and make them better at catching these new AI-designed threats. The big question was, would the patches actually hold up against something like a fragmentation attack? Which brings us to the results. And what they found, well, it was a classic case of good news and some pretty serious bad news. Okay, before we dive into the charts, you just need to know about one quick thing, the Matthews Correlation Coefficient, or MCC. Just think of it as a report card for the software. The score goes from -1 to +1. A score of 1 is an A+, a perfect grade. It means the tool correctly spotted all the threats and all the safe sequences. Anything less than 1 means it's making some mistakes. All right, so let's start with the good news, because honestly, it's pretty impressive. It turns out that against these advanced, fragmented threats, our patched digital defenses performed surprisingly well. They're actually a lot stronger than we might have feared. Now, check this out. What's really cool here is how those top lines, especially the solid blue and green ones, are climbing right up towards 1.0. That's our perfect score, remember. This shows that the best tools were really good at detecting threats, even when they were chopped into tiny little fragments, as short as 50 nucleotides. That is a huge win for biosecurity. But, and you knew there was a but coming, right? While these tools are good, their effectiveness has a very clear and very important breaking point. These charts, well, they reveal that breaking point. The horizontal line at the bottom shows how similar a fragment is to a known threat. The bright yellow areas show high detection rates. That's where the tools are working perfectly. But as you move to the left, into those dark purple zones, that's the blind spot. When an AI-designed sequence becomes too different, too novel, the tool's detection rates just plummet to almost zero. They go completely blind. And that right there, that blind spot, it reveals the fundamental limit of our current approach. It points directly to what has to come next in this escalating race between biological design and our digital defenses. So let's just recap the big takeaways here. First, today's best screening tools, they're impressively effective, even against these tricky, fragmented AI threats. That's great. Second, their total reliance on looking for similar sequences is a critical, baked-in vulnerability. And third, as AI tools get better and better at creating these weird, novel proteins, we're going to need a whole new approach, screening based not on what a sequence looks like, but on what it does. The researchers themselves end on a pretty stark note. They say that we have to continue to act with urgency to create BSS tools that can meet tomorrow's threats. You can really feel the weight of that. The race is on, and we absolutely cannot afford to slow down. So what this research shows us is that our digital immune system, it's working pretty well for now. It's been patched, and it's holding the line against the kind of dangers we can engineer today. But the question that should really leave all of us thinking is this. As AI's abilities keep growing exponentially, will our defenses be ready for the threats of tomorrow?